So looking at this problem, there should be a hierarchy for integration. I think you and I did go over the hierarchy of steps when approaching an integral. Do you remember what they were?
I know there's U sub. There,
Okay, but before u sub,
oh,
there's what do we try?
algebraic manipulation.
Okay, first we can do them separately, right? If they're plus or minus,
Oh, okay.
and then do some algebraic manipulation. What else falls under this branch of manipulation? Algebraic, or what other kind of manipulation can you do?
Long division.
Well, that's part of algebra. Think outside algebra box. Trigonometric. Okay. What do I mean by that? You can use an identity. Okay. You can turn cosine squared theta into 1 plus cosine 2 theta.
Mhm.
You can't integrate the first one of cosine squared, but you can separate these two, right? 1 half plus cosine 2 theta over 2. And these two are, you are able to integrate.
Mhm.
So the identities. Then you get onto u sub. And then if that doesn't work, what should you try?
Integration by parts.
Good. And then if that doesn't work, it's one of the special techniques. All right?
Hmm.
If you haven't written this down somewhere in your notes, write it down now, please. Okay. So, what's the first step in a partial fractions problem?
You you factor at the bottom.
Good.
First you can factor out a x from there.
Okay. And when I factor out an x, what's left behind?
X squared plus 2x plus 1.
Good. And then what does that factor into? Does this trinomial factor at all?
Uh, X plus 1 times x plus 1.
Good. If you don't recognize this as a perfect trinomial square, the way you would recognize it is when you square root x squared, you get x. The square root of 1 is 1. 1 times x times 2 is the middle term. So it's a perfect trinomial square. So you can immediately go into taking those two square roots, adding them, and doing that. Okay? If not, you can do factoring by grouping or your guesswork factoring, however it works. But yes, this is correctly factored. Now what do we do?
Then you write it into like a over x plus b over x plus 1 and then plus c over x plus 1
Is that it?
and then plus c over x plus 1.
Good. Just x plus 1?
Oh, squared.
Squared. Good. So now what's the next step in partial fractions?
This is the part where I get confused.
Okay, well, what you got to do is you got to multiply both sides by the denominator. And when you do it on the left side, it cancels out completely.
Mm-hmm.
If you multiply both sides by x times x squared or x plus 1 squared, canceled here. What cancels whenever I multiply by a over x? The x's cancel, right? Do you
Mm-hmm.
see that? X over 1
Yeah.
cancels with that. What are we
And then
left with?
so the a would be like a times x plus 1 squared.
Good. And then plus b times x plus 1.
Mm-hmm. And
And
then
then what's the last one going to be?
plus c times x.
Good. And then on the left
Oh,
side, we can just write down the denominator. Did you get the light bulb moment?
yes.
Light bulb. All right, so then now that we've done that, because the denominator is smaller or larger than the numerator, we can just let x equal different values. If the numerator is larger than the denominator, then we have to multiply it out and equate the coefficients. Okay? So here our denominator originally was cubed and the numerator is squared. Okay?
Mm-hmm.
So what we can do is let x equal different numbers. So what can we let x equal? What do you think would be a good idea? The goal is to make two of them cancel and have one of them stay behind when I assign an x value. So what can I let x equal on this right-hand side to where either a and b go away and c stays, or b and c go away and a stays, or a and c go away and b stays? I'm assigning a value to x to plug into here. And when I plug in that x value, two of these ABCs go away and one stays behind. So what can I choose for x?
0.
0 works. When I let x equal 0, b goes away and c goes away because of these x's. Do you see that?
Mm-hmm.
Okay. So now that we've done that, let's plug in. The left side is going to all cancel except for the 6. So we have 6 equals, and then 1 squared is what? 1. So we have, here, I'll just go ahead and plug it in for the sake of people that might watch this later. And then when you simplify that, you get that a is equal to 6. You see that? Now we repeat the process. What else can I let x equal to where two of them disappear and one of them stays behind?
-1.
Good. Which two go away?
A and B.
Good. And then the left side, when you plug in a -1, you get this. And then the right side, when you plug in a -1, you're going to get... Do you understand? So 11 minus 20 is -9. Okay? Now that we know A and C, what we can do is we can choose an arbitrary value for x and plug in this A and C into this equation. So when I do that, I'm just going to choose 1 because 1 is nice and easy to deal with. So I would get 5 plus 20 for letting x equal 1. Plus 6 equals A was 6 plus, or times 1 plus 1 squared, plus B we're looking for, plus 1, plus C was 9 times 1. Do you understand what I've done there? All I did was plug in my A and B,
Mm-hmm.
or A and C, sorry, and chose an arbitrary value of x, and I chose 1 because 1 is easy to multiply and square and stuff. So the left side gives me a 31, and then here we get 2 squared is 4 times 6 is 24, plus 2b or not to be, that is the question, apparently, according to Shakespeare. I don't see how that's really a question, though. I mean, if I had a choice between being and not being, I would choose being. I guess I don't know what the other side's about, huh?
Maybe because
Am I getting a little too?
maybe because he lost his mother
Go ahead.
and his father. Well, he
Was
didn't
he
lose.
depressed?
He didn't lose his mother, but his mother went with his father's killer. So I guess he felt betrayed.
Yeah, yeah. I guess so. It could be. I guess that's why he was so depressed. So 6 and then 3 gives me a 33 here, and this is the 31, and this is 2b. So at that point, we subtract this over. You get a -2, -1. Okay.
Hmm.
So there's your B, and you got your A and your C. So now what we got to do is we got to look at the original problem and plug back in. So A was over X, so the integral of 6 over X. And then B, I'm getting this from the original point that we broke them apart. B was -1, so it's -1 over X plus 1. And I'm running out of space. And then 9 over x plus 1 squared. Now, this problem is equivalent to what we started out with, but should be a lot easier to solve. Would you agree with that statement? Is this
Yes.
problem a lot easier to solve?
But what happens to
So what's
the numerator?
what do you mean?
Like, are we just gonna ignore the like numerator part?
The numerical numerators or the old numerator?
The old numerator.
Yeah, it's no longer that fraction we had is equivalent to the sum of all three of these.
Oh, okay.
So if you were to find common denominators, and after you found a common denominator, multiply the tops and simplified, you would get that other fraction. Do you understand?
Yeah.
Okay. So what's the integral of the first one?
It would be
Do you know how to integrate
it'll
6
be
over x?
ln of x.
Go ahead. Good. And then the next one, do you know?
It'll be minus ln absolute value of x plus 1.
Yes, and technically what you should do is show your work for an exam, I would think. I don't know how picky they are on these, but it would be the integral of -1 over u, which is ln of u negative. And then you plug back in to get negative ln of x plus 1. What about the last one?
Would it just be 9 over x plus 1?
It would, Mr. I like to not show my work. It would be a u substitution again. It would be the same substitution as above.
Mm-hmm.
The only difference is the problem would change to 9 times u to the -2
Mm-hmm.
du. And then you're right. When you integrate that, you're going to get 9 u to the -1 over -1. So then you bring it down and write it with the rest of them. So it would be plus 9, or actually, no, sorry, minus 9 over u, which is x plus 1. And we're done, right?
Let's see.
I thought I was going to get to tell one of my tutors to find the magic marker or the permanent marker and put plus C in the back of your hand, but you remembered. Good job. So do you understand the basics? Do you understand the fundamentals?
Yeah.